everyone, welcome to Brody's lecture video for the 9th part in our weekly practice, and today's topic is permutation and combinations. Now, these two topics are considered two of the most difficult topics even in the international competitions, all right, because they contain a lot of advanced skills. But today we're just gonna talk about the basic and what's the difference. Now, permutation and combination are quite similar in fact, but the which makes the difference is either the order makes sense, all right. If the order matters, then it's permutation, and if it doesn't, then it's combination. Let's see some very simple examples, all right. If we have an A here and I have a B here, if AB is not the same with BA, then it's permutation, all right. And if AB is the same, all right, with BA, which means the order doesn't matter, right? Who stands in front of it doesn't matter. Now, this time is combinations, all right. So let's see today's question. We have two questions, but there are a lot of little questions here. All right, the first is a 4-digit password is formed by a permutation of 1, 2, 3, and 4. All right, a permutation of 1, 2, 3, and 4. Now, each number will be used only once, which means a password such as 1122 should not exist. All right, it doesn't make any sense. All right, so now the first question would be how many different 4-digit passwords can be formed? All right, can be formed. Now, this is a permutation of a 4-digit password. All right, so we draw 4 blanks here. And for the first blank here, we have how many choices? How many choices? We have 4 choices, right? We can put 1 or 2 or 3 or 4 here. So there are 4 choices in this blank. And how many choices left for the second one? For the second one, now we have 4 numbers. All right, 4 numbers here we can write down in the first place. And we've used one of them, so which means only 3 remains for the second, right? Because, for example, if we put 4 here, all right, we use red maybe. We put 3 here, all right? We put 3 here, then 3 is already used. What is left are 1, 2, and 4. Right, so 1, 2, or 4. All right, so 3 choices. Now, what about the third place? What about third place? We used 1 more, so there are only 2 left, and then 1 left. All right, so in total, we should multiply them. All right, we should multiply them. It would be 4 times 3 times 2 times 1, which would be 24. All right, which would be 24. So 24 different 4-digit passwords can be formed. All right, now the second question asks if the last digit of a password is an even number. All right, guys, an even number. Even number here, 1, 2, 3, 4. What's the even number of these 4? All right, it should be 2 and 4, right? 2 and 4 here. And how many different passwords can be formed? Now, remember this, when you are solving a permutation question and there are special requests or requirements for a certain place, for example, the last digit, then we consider this place to begin with. All right, we consider this place to begin with. Now, still we have 4 places, but now we first consider this place, because we have a special request that this must be an even number. So we have only 4 or 2 here, which means there are only 2 choices. All right, 2 choices. Then we deal with the rest. All right, we deal with the rest. So this place, we use 1 here. So there are only 3 choices here, 2 choices here, 1 choices here. All right. So in total, this should be 3 times 2 times 1 times 2, which would be, of course, 12. All right. So only 12 different passwords satisfy the second question. All right. Because we have a special request for the last digit. All right. And we deal with it in the first place. So the third question would be, if the last digit, again, we have a special digit, all right, a special requirement for a certain digit. Now, a password is an even number, all right, still even number, and the first digit is an odd number. Now, an even number for the last digit and an odd number for the first digit. All right, so how many different passwords can be formed? Still, we have 2 places. All right, we have 2 blanks to fill in. And the first, the last are special. All right, they are special. And we get 2 and 4 for the last digit, 1 and 3 for the first digit. Luckily, these 2 blanks, the numbers are quite different. All right, are quite different. So we have 2 choices here and 2 choices here. All right, so now we've used 2 of the 4 numbers. So what there are left are only 2 numbers. All right, so 2 choices here and 1 choices here. So 2 times 2 times 1 times 2, that would be 8. All right, so 8 numbers. All right, 8 different passwords. So this is the answer and how to solve it of the question number 1. All right, so let's see the question number 2. There are 3 boys and 4 girls in the class. All right, 3 boys and 4 girls. All right, so if 4 students are chosen to form a team, 4 students, and this team must consist 2 boys to take part in. All right, 4 students, 2 boys. All right, 4 students, 2 boys. So how many different teams can be formed? Now, we can see this is a combination question because the order doesn't matter. All right, doesn't matter. It doesn't matter if the boy is the first or the second or the third and the fourth. They are the same. All right, so we just need 2 boys, and these 2 obviously are girls, right? Are girls. Now, how do we do it? So if we choose randomly, all right, if we choose randomly, there are 4 girls. All right, we need to choose 2 girls. All right, 2 girls of the 4. So how many choices we have? It would seem that we have 4 choices here and 3 choices here, right? Because we have 4 girls and then 3 girls. But if you consider more carefully, you will think that there are some repeating here. All right, some repeating here, because if we name the 4 girls A, B, C, and D, then you will see that if we choose A in the first, B the second, it's the same to if we choose B in the first place and then followed by A, right? These 2 choices are the same. All right, so girls, we have 4 times 3, but we must divide them by 2. All right, so it's the same for the boys, right? Because boys, we have 3 times 2. We have 3 choices here, 2 choices here, but still need to divide them by 2. All right, because it's still the same, right? AB is BA. All right, so we time them together. All right, we multiply them. So it will seem that these are the result should be 18. All right, the result should be 18. So this is the first question, and let's take a look at the second question. If 4 students are chosen to form a team, still 4 students, all right, are chosen to form a team, this time consisting of at most 2 boys, all right, at most 2 boys to take part in a competition. Now, how many different teams can be formed this time? All right, so I believe that the best way is to think otherwise, all right, to think otherwise. At most 2 boys, which means you can have 0, which means none boys, all right, or 1 or 2, right? But if we think otherwise, there are only 3 boys, all right, there are only 3 boys. So if we consider all the situation, we can see that there can be none boys, or 1 or 2 or 3, all right, or 3. This means all the boys should be chosen, right? So if we think otherwise, then if we have 3 boys, all right, if we have 3 boys, which means among the 4 places, 3 of them are boys, which means only 1 girl, all right, only 1 girl. Now, why the Brody sir highly recommend this? Because if we choose 3 boys, there are only 1 option, all right, only 1 option. You need them all, right? You need each and every one of the 3 boys. And what about the girls? We have 4 girls, right? So if we have 3 boys in the team, then there are only 4 kind of different teams, all right? And this is the 3 boys situation. We just need, if we need to know the 0 and 1 and 2, we just use all the situation to minus this, right? So if we can see all the situation. Now, this is a little bit difficult because the expression could be very, very complicated. There are 7 boys and girls, all right? There are 7 of them, all right? So if we choose randomly, then it would be 7 times 6 times 5 times 4, right? And of course, think about this, all right? This time, A, B, C, D is the same as D, C, B, A, and maybe B, C, A, D, and so to speak, right? So how many? In fact, there are 4 times 3 times 2 times 1. Because we have 4 team members, which means who can stand in the first place. There are 4 choices for the first place, 3 choices for the second, 2 choices for the third, and the last one is decided, right? So 4 times 3 times 2 times 1. Now, this is a little bit difficult, but still, the answer would be 35. So the real answer of this question should be 35 minus 4, which would be 31. All right, this is our final answer. All right, and this is also a very, very useful method that you think otherwise. All right, we don't think about the none and the 1 and the 2 situation. We think about the 3 boys situation. All right, 3 boys situation. And we calculate this and calculate how many situations are there in total and minus them. All right, so this is all for today's lecture. And just to remind you, these 2 questions, we modified them from real DSE papers. All right, which means they could appear in the final test, which would be appear in the DSE maths. All right, So I hope you really look carefully into these two questions and find the answer by yourself. Thank you. Goodbye.